Welcome to the fifth edition of our FAIRWork webinar titled Ethical Reflections in FAIRWork. We have our experts here with you, Professor Böschen, Johanna, and Mareike. And I wouldn't like to spend too much time on introducing anything on the topic, because it's, I think, a very interesting thing that we're going to experience in the next minutes, and hand over to our presenters. Thank you very much for your time. Thank you for the presentation.
Yeah, thank you very much for giving us the opportunity that we talk. Sorry, did you want to say something, Stefan?
No worries. We would like to offer you an opportunity to think with us about this FAIRWork ethical framework we developed so far. And we have the great opportunity today that we do it in a way that we have Mareike Smolka with us, who is expert in this so-called STEER method. And we would like to bring these two insights into a conversation. So therefore, we will see that we first introduce our framework so far developed, and then to hear something about the STEER method. And finally, we will have a short conversation about how these two approaches fit together and how we should come into a conversation about ethical issues which might emerge in the FAIRWork research we do so far. So with this, I hand over to Johanna.
Thank you very much. Yeah, as Wilfried said, we will shortly introduce ourselves maybe. So I'm Johanna Wertz, working as a research group leader at the Werkzeugmaschinenlabor at the RWTH Aachen University. And maybe Stefan, would you like to say just really quickly who you are, and then I can further.
Yeah. My name is Stefan Böschen. I'm Professor for Technology and Society at RWTH Aachen, and as well spokesperson of the Human Technology Center at RWTH Aachen.
And Mareike will introduce herself when she'll start. Wonderful. Okay, so our agenda for the webinar today is the following, and I will just, instead of reading it for you, I will just jump right in with a short introduction and background about, where are we? So when setting up a project like FAIRWork, we have to consider all content and a lot of different things. And one question is, of course, also that we have to respect ethical guidelines throughout the project and also beyond the project. And the EU gives certain guidelines for EU-funded research that one has to adhere to. So these are the following 6 ones on the left side: the principle of proportionality, the right of privacy, right to the protection of personal data, of physical, mental, and integrity of all persons involved and also touched by the project. Of course, the right of equality and non-discriminations, and also protection of the environment and human health. And these guidelines, as broad as they are, well, we have to respect them and have to make sure that FAIRWork sticks to these. And on the other hand, there is a high-level expert group on artificial intelligence from the European Commission that worked specifically on AI and published first a definition of AI in 2018, then ethic guidelines for trustworthy AI in 2019, and then finally also an assessment list for trustworthy AI in 2020. And you can see that one on the right-hand side. And they have also these seven guiding principles that when developing or working with AI, one should take into account. And we will hear a little bit more about these guidelines later. And in the end, these guidelines link to or lead to the fact that AI, or let's take it a bit broader and say technology is lawful, so respects the laws and regulations that exist within the EU, that it is ethical, so respect ethical principles and values, and that it is robust, so also from a technical perspective, but also social environmental questions. Yeah, so this is basically what these 7 points link back to and are based upon. As I said, we'll come back to the 7 ethical guidelines in a minute. Before that, maybe one more sentence about fair work, because when looking for what does complexity mean in ethical issues, we find that complexity arises when methods or outcomes from projects are complicated, or when technologies are involved that have not been sufficiently tested, or in the final point, when they raise multiple or intersectional ethical issues. And these are, of course, points that we will touch in fair work, but let's be honest that most technological projects nowadays, they find themselves under these definitions. So most technological, or especially socio-technological, as fair work is, socio-technological projects, research projects nowadays are complex, and this means that they require high standards of ethical reflections. And what is the specification of socio-technical interactions is that they are very, they are very specific, and it's hardly possible to have general criteria, but that ethical issues always arise in very concrete cases. So our goal was to set up a general framework to be able to reflect ethically and ethical issues and identify ethical issues and also solve them, but a framework that is loose enough to be open to find to apply them for these concrete cases that might arise. And this being said, how the approach that we chose, or that we have developed for, until now, is the following, and I will shortly introduce it. So we have the very general procedure that we want to identify ethical challenges and then review the instruments that we have, or that we have to develop, and then bring these two together. So which instruments do we have, which processes do we have, and then of course review the processes that we have taken and that we have decided to take. And of course, at the end, we don't want to do it only for ourselves, but also learn from it. So we have to archive it and also, transport it into a scientific or community who's interested in the ethical reflection topics. Today we will mainly talk about the first 2 points, because we're starting and we want to give you a hint of how we want to identify ethical challenges and review the instruments that we have. So along the 7 points of ethical challenges that the EU, the AI Commission of the AI Commission of the European Union identified, we can find 7 dangers that arise when we do projects. They range from a danger of life and health until the replacement by machines if humans are involved or can be replaced by machines. And of course, all these challenges have to be taken into account, and we have to take care that exactly these dangers do not happen. We set up the following matrix, or the following table, to identify, or to be able to identify ethical challenges in a more structured way. We have in columns, we have here the question of whether people are directly involved in an interaction, socio-technical interaction situations, or whether they are only indirectly involved. So indirectly would mainly mean they are represented by data points of whatever kind, and directly would be something like interviews, people really being present. And then in lines, we have the research situation, or the way of the situation in which we find ourselves. So we have the research situation as the first line, and the second line would be prototyping or test operations, or one step further into application. And then the final line would be the real life operation, where we have, well, yeah, where the project is not any longer in the researcher's hand, as so to say, maybe, and mainly, and also, of course, after the project, when it's really on the street. And so taking these columns and lines together brings us possible interaction situations that are that we have to take care of, and especially in focus, or especially demanding, let's say demanding for ethical challenges, is for sure the real life operation, the final line, because, as I said, they are not this line or these situations are not in the hands of the researchers any longer, but they we have to think into the future when we consider these situations. I will give you 3 examples of how this matrix can help to identify dangers or ethical challenges. So the first one would be a data explanation. Of course, these are only hypotheses, so these are not that we are in the project experiencing all of these examples, but it's just to give you an example of how to use the matrix. And so if the data example would be, if you have to consider privacy and have to grant privacy and data governance, we have to be sure that we always be sure that people are consensually participating or are voluntarily participating in our research. And this is something we can grant this in direct human involvement and during the research situations, because we are able to ask people whether they want to participate or not. But as I already mentioned, in real life operations, these situations are out of our hands, and there might be situations when a company says you now have to participate and interact with AI, for example, and this is not voluntary anymore. And this, of course, is a problem and poses a danger to the guideline of consent and voluntariness. Next situations would be AI transparency. So we have to grant AI transparency and want to give humans the opportunity to have always insights into processes and applications. And this is something we can grant this insights into processes and applications when we work with humans directly, when we can interact with them directly. But once humans are only involved, as I said in the beginning, via data points, for example, this can pose a danger. And yeah, so this is the red marked here. So we have to take care that humans, despite only being represented, for example, as data points, they still have the opportunity to look into process and applications. And the final example would be robotics. So we have to grant technical robustness, as the guidelines say. So we can only, this leads to the fact that we have to use stable, well-tested technology. Well, in a research situation, this can be a bit dangerous, because can be not dangerous, but this can be threatening of this guideline, because we have to work with robots that might not be completely well tested, but that might be in development phase, for example. So especially when prototyping, as the word says, we are working with prototypes. So that might really not be a stable, well-tested technology. Whereas this, for example, in real life operation, will be a less threatening challenge. Where so just as an example, how we can use the matrix to identify and make a bit more strategic decisions for how to look at ethical challenges. And maybe one step further, what we developed, I will not go through it in detail, is simply a decision tree of how to think about ethical challenge, just as a very, very initial step, where we basically ask people, is it possible to replace humans? Then please do that. Is it possible to contact humans? So is it direct? Do we have direct contact to the humans? Then we have to grant voluntariness and consent. And if it's not possible to grant voluntariness and consent, is it at least possible to grant anonymity? Then we have at least to grant this. And if these three principles, if we cannot grant these three principles, well, then we have to really look into this, the specific situations, because then it gets more complicated. Just as an example, what we set up for ourselves. And then, of course, in the end, it's always important to run a risk assessment, where the European AI Alliance set up a portal for checks. And there are also other ethical assessments that you could use, like ECOLA. Or you could also use the STIR method, but we will hear about that in a minute. And then once you have identified the problems, we have a hand of instruments that we could use, that we just randomly sampled here. There are more than that, and of course, maybe the most important factor or most important point beyond, we could use simulated data, or we have to anonymize, pseudonymize, we have to be transparent about AI processes, and so on. The most important point is that to translate ethical principles into practice, you always have to take care of different contexts and situations. So it's not possible to find this one instrument that will always fit, but it's always a discussion between situation, context, and then which possible instruments do we have. And yeah, talking about this discussion, I want to introduce, or I want to hand over to Marijke Smolka, who will introduce a method that is a chance to explore the matter a bit deeper. And also, without saying too much, I think it's also a little bit of a different approach than traditional ethical checks, because it is this idea of discussion that is required to really find solutions, and not just one size fits all, because it's not possible in this domain. So yes, I think she'll explain everything a lot better than I do. So I'll happy to hand over, and thank you that you're participating and sharing your expertise with us.
Yeah, thank you for the invitation. This is indeed a perfect transition. Maybe you can go to the next slide. Yes, so hello everyone, I'm Marijke Smolka. I work as a postdoctoral researcher and the coordinator of the Collaborative Innovation Research Group at the Human Technology Center under the direction of Stefan Böschen. And I've experienced with socio-technical integration research for roughly 5 to 6 years now. Next slide, please. In this presentation today, I will first start with the history of the development of the method, and then I will go into the practicalities, and I will also tell you how you can learn more about the method if you're interested, before we then explore together how the method could be helpful also for the FAIRWork project. So the STEER method was developed in the early 2000s in response to the 21st Century Nanotechnology Research and Development Act passed by the US Congress. And this act was developed because at the time there was quite some hype, but also a critical backlash against nanotechnology. So the question was not only what can that do for society, but are there potential harms? Are there risks of pollution for health and so on? And in the act, the idea was, okay, if we integrate social scientists or ethicists into nanotechnology research projects, then we can think about the social and ethical dimensions of that work, its potential societal impact already in the research process, and prevent that we are developing technologies that are not desirable or acceptable in society. And Eric Fisher, the developer of the STEER method of socio-technical integration research, he picked up on this act and developed a method in collaboration with engineers from the Nanotechnology Research Group at the University of Boulder in Colorado, which basically does the work of integration, of integrating him, Eric Fisher, as a social scientist / humanities scholar in this nanotechnology research environment. And this is also where he conducted his first STEER pilot study with the research group, and later on also got a grant for 10 comparative STEER studies to find out how the method plays out in different cultural contexts in order to see whether there is a difference in terms of culture with regards to how social and ethical aspects are taken into consideration when people are working with this specific reflection tool. This is how I would call the method. Next slide, please. So you see here an overview of the different countries where STEER studies have been conducted over the last, by now it's almost 20 years. Recently also studies in the Global South became part of the pool. Next slide, please. And a number of studies have been published that show that indeed STEER can support researchers and engineers to take ethical questions into account as part of their work. Next slide, please. And this also brings me to the aims of the method. So STEER is all about opening up reflexive spaces and dialogues and group discussions. And just as Johanna mentioned, it's not about basically having a one-size-fits-all approach or having an ethics committee that simply says this is okay and this is not, and strict rules, but it's really about engaging individuals who are involved in the research and development process in reflection on the social and ethical aspects of their work. And in that sense, decisions are taken as the starting point, because in research and development, people are making decisions constantly. What kind of material do I use for an experiment? How do I introduce this questionnaire to a participant? And so on. There are numerous examples of very trivial decisions where still values are at stake. Is the material environmentally benign? How much does it cost? And so on. And in that sense, when we are making decisions, we can also explore alternative courses of actions and maybe take actions that are more socially responsive than others. In that sense, the STEER method really aims at expanding individual and organizational rooms for maneuvering, because what you often see when you talk to natural scientists and engineers, then this is that they say, you know, ethics, this is not part of my job. This is part of the job of an ethics committee, but I'm really just here to do the science, or nothing really responsible goes on here. I'm not interested in politics. I'm a researcher. And this is in a way a conception that STEER tries to challenge a little bit by saying, no, in fact, the social and the ethical are part of research and engineering practice, because this is where we make decisions about how to design the technology, how to design the artificial intelligence, for example, that is at the heart of FAIRWork. And in that sense, it's really a long-term goal to support a social and cultural, but also an institutional change to take responsibility for the ethical and the social in research and development processes. Yeah, one slide back, please. Exactly. So how does STEER pursue these aims? There are three methodological pillars of the method. First, the decision protocol. Second, an embedded humanist. And third, the midstream modulation analytical framework. And I will briefly go through these different pillars. Next slide. Yes, thanks. So this is the decision protocol. So what is STEER doing? Usually you have a social scientist or an ethicist embedded in a natural science or engineering environment where he or she stimulates reflexive dialogues by following the decision protocol. And so the decision protocol is really an object to facilitate the interdisciplinary collaboration and to think about the values at stake in decision-making processes, and to also unravel if there is maybe an ethical issue or question that's addressed here. And you see here that STEER divides an opportunity for decision-making and four conceptual components. So first, it's about identifying an impending decision. What is the researcher or engineer currently dealing with? Then it's about looking at the criteria for responding. So what's at stake here? What's important? What are possible values to consider? And then also, what are options for responding? What are alternative courses of action? And then in the last quadrant here of the decision protocol matrix, you see it's also about anticipating the possible effects of taking a specific decision here. Next slide, please. And as I mentioned before, usually the dialogues, the reflexive dialogues between the humanities or social scientists, the humanities scholar or social scientist on the one hand, and the natural scientist or engineer on the other. These are facilitated by the decision protocol, but also by a so-called embedded humanist. And that's the name we give to the social scientist or humanities scholar, because this person is not only in charge of the reflexive dialogues, but usually that person is embedded in a natural science or engineering environment for a period of roughly 12 weeks. That's the classical STEER study design, to also observe what's happening so that he or she gets a better understanding of the kind of technology that is developed. So it's really also working with ethnographic methods to support the reflexive dialogues that the embedded humanist is facilitating. And she or he has also different rules for engagement, because this is really about taking on the role of a midwife, you could say. It's about minimizing one's own appeals to one's expertise or values, and also actually only engaging with the values, principles, and concepts that the natural scientist or engineer uses or recognizes, because the focus is here that on facilitating reflection, not on pushing specific values onto the collaborative partner. And so whenever this may happen, then it's important to note that and to document that and to make that very explicit, because the embedded humanist is really rather the one enabling self-reflection on the social and ethical aspects of scientific work. Next slide, please. Yeah, and then you see here finally the midstream modulation analytical framework. This is used in order to look at the effect that the STEER method can have on research and development processes. And it's called the midstream modulation framework because when it comes to ethics and society and research and development processes, usually in the past we focused on the upstream. That's, you know, getting the ethics board approval, for example, or getting an authorization. Or we focused on the downstream processes of regulation and application, where then the question is, once research and development is over, we have a certain technology in place. So now it's up to the regulator to see how, when, and if it can be used. And this idea of thinking about also the governance of technology is a little limited because it leaves out the actual research and development process where scientists and engineers make a lot of decision and where actually they can also change their decision-making processes and their actions so as to take a wider horizon of social ethical considerations into account. And the midstream modulation framework traces this by looking at what kind of social ethical considerations already influence research and development, often without the engineer or natural scientist being aware of that. And then also it looks at moments when through the use of the decision protocol, researchers or natural scientists become more aware of such de facto modulations of the social and the ethical in their work. And this can then often lead to these natural scientists and engineers actually changing their activities, strategies, or discourses. Next slide, please. And I just wanted to bring you an example to make this whole thing a little bit more concrete. This is the STEER pilot study, where you see that Eric Fischer, he worked with a nanotechnology researcher who was trying to grow tubes on a fiber. And for that experiment, he needed a catalyst. And in the STEER exercises, they were thinking about what kind of catalyst to use. And the first idea for a catalyst he had, that was a catalyst he described as messy. And through the reflexive dialogues, they unfolded that messy meant here a material that is not sustainable, that is not environmentally benign. And then again, over the course also of multiple weeks and of multiple interactions and again with the decision protocol, the nanotechnology researcher decided to use another catalyst that had less adverse effects on the environment. And he also, at the end of the 12-week study, concluded that without the STEER method, the research project would have been a whole different thing, because ultimately the experiment did not only turn out to be more sustainable, but also it was epistemologically successful, meaning that the researcher could grow tubes in a fiber and confirm his research hypothesis. Next slide, please. I also just wanted to bring you some examples from my own research. I used STEER in my PhD study in different modalities, actually. I already mentioned there is this classic setup of a 12-week STEER study. This is also what I did with 4 different participants, all working on the topic of mindfulness meditation and how it can improve healthy aging. I interacted with researchers and other members of the team in bi-weekly interdisciplinary reflexive dialogues, but I also organized group discussions with with them to discuss socio-ethical challenges that I found out to be relevant for the entire group on the basis of my ethnographic field work, of my participant observation in the group, because I was with the team also first for 12 weeks and then again during a later phase, roughly a year later. And so this is also, I'm presenting this because thinking about steer and different modalities could also be relevant for the FAIRWork project. One last modality we tested in online workshops was to give the steer protocol to researchers all working on the topic of mindfulness, and to have them steer one another, so that this is not relying on a social scientist or ethicist facilitating the process, but that it can also be used within a group of researchers to stimulate reflections. And yeah, there we tested the method with 25 participants, and we're now still in the process of getting this study through peer review. So this is my experience. And next slide, please. This brings me to the end. I just wanted to let you know that if you are interested to find out more about the method, we have recordings of a STEER seminar series that we organized last year. All the recordings and the corresponding papers are online. Also during that time, we started to organize bi-weekly online STEER practice lab sessions, also with Eric Fisher, the developer of the method, and everyone is free to join there. So please contact me or Eric Fisher in case you're interested to join, to find out more about the method and to meet the STEER community. Thank you.
Yeah, thank you, Mareike, very much for this insight into the STEER method, because it's really important not to have this reflexive turn in doing engineering, in doing science, doing research. And it's therefore it's a strong alignment I see with regard to what you do and what we should perhaps do in our ethical framework. So we should put some questions on desk, I would say. It's put on the next slide that we see, and especially 3 questions which we should confront ourselves with. Because first, the STEER approach sounds really like a promise to enrich the FAIRWork ethical framework, so far elaborated. And what are the most important hints stemming from this methodology? So I would say in the first look that we have this different interaction situations, socio-technical interaction situations, and that we should go through them and ask ourselves, well, what might be in these cases relevant interventions, questions we can take there. And I would say it's really interesting to say that we have a lot of these different situations. So it's not only with regard to our own research group in FAIRWork, where we have the different disciplines on board, but it's also with regard to our practice partners, that we have there really different decision processes. So it's not only about a good research, but it's about organizing engineering and reorganizing also production lines, which is in the very focus of FAIRWork. And therefore, this brings me to the second question. It's about our case studies, so that we really should take into account that we reconstruct these more in a way that we see here decision-making processes at really different levels. And then the question we should put on our desk, how these insights we have steer towards specific decisions for the design of the models and the processes and the scenarios so far, how these production lines are controlled, and what are scenarios, what things are running bad and wrong, and then what are the decisions which are aligned to these situations. And therefore, I see a good point to integrate here the hints, the methodological hints of the STEER method to our approach here. So I see really the enriching potential of this STEER method for our research and ethical reflection. But no, I do not know whether you, Mareike, or you, or Johanna, would like to put some points on desk. Otherwise, I would say we have a good point found.
No, I can continue. I see different possibilities for working with the STEER method in the context of FAIRWork, because ultimately, I mean, you are developing a technology, and often there are ethical issues that you can't really foresee by just thinking about it, but that really pop up in the process. So I think it's important to regularly have reflexive dialogues with the people who actually execute the research and development. And I mean, you don't need to overdo it. I mean, STEER is really intense interaction, but even if you have such a conversation once a month, like, what have you been working on? Is there something that was challenging that you felt difficult? Because that's often when ethics come in, right? When it's not clear what to do now, when we can't do business as usual, but when we see something doesn't work here, and often we can't really articulate what the issue is and what's at stake, or that there's even an ethical issue, but something is bothering us. And I think it's these moments to zoom in and where you can get people on board in these reflexive dialogues, because STEER is very open, right? It just asks, what are you working on? What are you concerned with at the moment? Is there an issue in a way? Is there an opportunity? Also can also be possible. And I think it's very important to have this open focus, because otherwise, when you talk to researchers and engineers and you say ethics immediately, then they have already a very preconceived idea depending on the kind of discipline you talk to. So I worked with biomedical researchers. Ethics, it's all about treating participants, but ethics is much wider. It also goes into data, as we've just seen in Johanna's presentation. It also has to do with, for example, the materials used in the context of a clinical trial when you do PET scans, for example, right? So it can be a wider conception if you're that open. And I would encourage, let's say, the FAIRWork team to keep it that open and to search for the dialogue with the people who are actually doing the research and development, and to do that either in the context of, one-to-one dialogues. Maybe this might be a good first step, but to also do this in the context of a workshop, because we had good experiences with organizing workshops where we just put people together and they were sharing also with one another, because I think that's something we shouldn't underestimate, that of course in a community of researchers who have a similar background, also people easily understand each other and also have shared concerns and can help each other out in how to address them. But of course, I mean, this interdisciplinary approach is also helpful when you have a different person not sharing the background, who sees things maybe that the person very involved in the practice doesn't see. So they both have advantages and disadvantages, and you could play around with this. These are my suggestions. Thanks.
Yeah, wonderful. With this call, I would say we have done it so far. So thank you very much for attending to this webinar. Hope you take something with you, and we will further our conversation about these questions as long as the project is running, because these things, as Mareike mentioned, many things of these ethical issues are popping up, and then we have the questions to deal with. Thank you very much so far. Bye-bye.